fifth sum. U, V, W are complex numbers are related by these three complex numbers have a relation 1 by U equal to 1 by V plus 1 by W, where V is equal to 3 minus 4i and W, this is not U, W equal to 4 plus 3i. Find U in Cartesian form. Cartesian form is nothing but rectangular form. Rectangular form is nothing but the real and imaginary. First you need to write a real and then you need to write a imaginary. That's all. Solution. First write the relation 1 by U is equal to 1 by V plus 1 by W. We need to find U, but they given the relation 1 by U. So 1 by U is equal to cross multiply W plus cross multiply V divided by V into W. Now reciprocal. By reciprocating 1 by U becomes U. 1 by U becomes U. This reciprocal becomes VW divided by W plus V. Listen carefully. 1 by U is nothing but U. This reciprocal VW moves upward, W plus V comes down. That's a reciprocal. Now you can apply these two complex numbers in multiplication and these two complex numbers in addition. So U is equal to V into W. V is 3 minus 4i. This is 4 plus 3i divided by W plus V. 4 plus 3i plus 3 minus 4i. U is equal to, listen carefully, this is not a conjugate one. This minus 4i, this is plus 3i. These both are different, not conjugate. So you need to multiply. You can't use the formula 3, 4. You cannot use the formula a plus ib, a minus ib is equal to a square plus b square, because this is minus 4i, this is plus 3i. Both are different. 3 4s are 12. 3 into 3 plus 9i. 4 4s are 16 minus 16i. Plus into minus minus. 4 3s are 12. I square value is minus 1 divided by real and real. 4 plus 3 7 real. 3 minus 4 minus I is equal to 12 minus into minus plus 12 plus 12 24. 12 plus 12 24. 9 minus 16 which gives minus 7i divided by 7 minus I. 7 minus I. Then what do you want to do? The next format you can make it as always denominator should not come. This is also one of the complex number. This is also one of the complex number. Both are complex numbers. Mainly the denominators should not be in complex numbers. So we need to conjugate. 24 minus 7i divided by 7 minus I. Conjugate 7 plus I divided by 7 plus I is equal to first 24 into 7. 24 into 7 is nothing but 168. 168. 24 into I is 24i. Finally, 7 7s are 49 minus 49i. Minus into plus minus into plus minus 7. I square value is minus 1 divided by this one. You can write the formula 7 minus I, 7 plus I. Here A is 7, B is 1, I coefficient is 1. So 7 square plus 1 square. 7 square plus 1 square is equal to 168. 168 plus 7 is 175. How plus 7? Minus into minus plus, that is 7. 168 plus 7 is 175. Next, 24 minus 48. 9 minus 4 is 5. 4 minus 2 is 2. Nothing but minus 25i. In this 7 square is 49. 49 plus 1 is 50. 49 plus 1 is 50. So I can write 175 divided by 50 minus 25i divided by 50. So we can cancel in 5 table. How many times? 7 times. Sorry, we can cancel 25 table. This is 2 times, it is 7 times. 7 by 2 minus 25 50. The same 25 table. 1 times 2 times. 1 times 1 by 2 into I. Otherwise you can write the answer as, you can take 2 common, 1 by 2. 2 common, 7 minus 1 into I is I. 7 minus I. 1 by 2 into 7 minus I. Both answers are correct. You can write any one form or you can write both the form. It is very easy. If the sum prove Z is real if and only if Z is equal to Z bar. If and only if Z is Z bar. This one we have proved while in integration part itself. This one we can prove easily using a constant. If z is equal to 5, z bar is equal to 5, z is equal to z bar. For example, I have proved in integration part, if z is equal to 5, where 5 is real, z bar is also 5, therefore z is equal to z bar when z is real. We have proved using a constant. But using variable we need to prove. So solution, let z is equal to x plus iy. Let z is equal to x minus x plus iy. What will be z bar? Z bar is nothing but x minus iy. So we going to take this one and we going to prove this one. Z is real. That's all. What is mean by real? Real is nothing but we need to want one in the real and there is the absence of imaginary. That's all. Z is equal to z bar. So right, given, first we take given z is equal to z bar. Given z is equal to z bar. Since this is if and only, what is my if and only? We can say z is real, then z equal to z bar. Otherwise, z equal to z bar, then z is real. That is reversible reaction. Reversible moves left to right, and it can be moved towards right to left. It is a reversible reaction. So I am going to take z equal to z bar, then z is real. So as it is a if and only condition, I will put two arrows. This must you need to put. This implies z is z bar. What is z? Z is nothing but x plus iy. This is given. Z is x plus iy. Z bar x minus iy. This x we can cancel. Plus iy minus iy we can't cancel. Let minus iy come this side. Becomes plus iy. Plus iy. Another plus iy is equal to 0. Iy plus iy is nothing but 2iy is equal to 0. Y is equal to 0 divided by 2y. Y is equal to 0 divided by 2y. Therefore, y is equal to 0. Since y equal to 0, it shows z is real. Y is 0 means imaginary is absent. Imaginary absent, no. See, imaginary is absent. Imaginary is absent. Only x is present. Only x is present. So since it is, listen carefully, since it is if and only condition, we need to put each and every line, we need to put this implies. So each and every line you need to put. So finally z is real. This is first subdivision. Next I need to prove for second subdivision also. The second subdivision is this very second subdivision we have proved already also. So once I will prove second subdivision. What is second subdivision? Real part of z is equal to z plus z bar divided by 2. You remember we have proved in introduction part. And imaginary part of z is equal to z minus z bar divided by 2i. We have proved. But once again, no problem. Let z is equal to x plus iy. First, let z is equal to x plus iy. If in this, what is real part of z? Real part of z is nothing but x. Next, what is imaginary part of z? Imaginary part of z. Imaginary part of z is nothing but y. Real part of z is x. Imaginary part of z is y. Real part of z is x, and imaginary part of z is y. So now z is equal to x plus iy. What will be z bar? Z bar is nothing but x minus iy. Add both this. Add z plus z bar. Z plus z bar is equal to x plus x, 2x. Plus iy minus iy cancel. Let 2 comes down. Z plus z bar divided by 2 is equal to x. What is x? X is nothing but real part of z. Real part of z is equal to z plus z bar divided by 2. This is the first in second subdivision part 1 we have proved. Next part 2. What is part 2? Z is equal to x plus iy. The same one. Z is equal to x plus iy. We going to show z is equal to x. Z bar is equal to x minus iy. Here we are adding. This one we are adding. This one we are subtracting. So this plus will become minus. Plus will become minus. Minus will become plus. Minus will become plus. Z minus z bar. Z minus z bar is equal to plus x minus x cancel. Iy plus iy, which gives 2iy. 2iy. Let 2i comes down. It becomes z minus z bar divided by 2i is equal to y. 2i is equal to y. What is y? y is nothing but imaginary part of z. Imaginary part of z is nothing but z minus z bar divided by 2i. So this is the second part of second subdivision. So very easy. Just we need to add, we need to subtract. This is adding. This is subtracting. So only we change the symbol, that's all. Sixth sum. Find the least value. This is an important one. Word least value of the positive integer. We know what is my integer. 1, 2, 3, minus 1, minus 2, minus 3, 0 also. So if we are going to one right number, 5, 6, 7. In this, which is the least positive integer? 5 is the least positive integer. 5, 6, 7. All the three numbers are least positive. All the three numbers are positive integer. In that, which one is the least means 5 is the least positive integer. For which root 3 plus I whole power n is real and imaginary. So I need to prove when it is going to be real. For which value of n is going to be real and which value for n which is going to be imaginary. So solution root 3 plus I whole power n. First put n is equal to 1. I am going to check with n is equal to 1. We are going to put in n is equal to 1, which shows root 3 plus I whole power 1. There is no change. Still it remains a complex number. This is real and imaginary. Real and imaginary. There is no absence of real. There is no absence of imaginary. They are asking real and purely imaginary. Purely. I left the word purely imaginary. So put n is equal to 2. Now I am going to apply n is equal to 2. So root 3 plus I the whole square. I can apply the formula a plus b the whole square. We know the formula a plus b the whole square. A square plus b square plus 2ab. This formula I am going to apply here. So I can write as root 3 the whole square. A square. Next b square plus 2 into a into b. A into b. So square gets cancelled. Nothing but 3. I square is minus 1 plus 2 root 3i. 2 root 3i. 3 minus 1 is 2 plus 2 root 3i. So leave it as it is. This is root 3 plus I the whole square. Next I am going to apply n equal to 3. Put n is equal to 3. We are going to put in n is equal to 3 root 3 plus I the whole cube. Root 3 plus I the whole cube. By putting root 3 plus I the whole cube, how the 3 can be written? Nothing but root 3 plus I the whole square into root 3 plus I. You can separate the powers because this is 2, this is 1. 2 plus 1 is 3. So you have followed root 3 plus I the whole square. Normally formed. Root 3 plus I the whole square is nothing but 2 plus 2 into root 3i. So this one is root 3 plus I. Now we can multiply 2 into root 3. 2 root 3. 2 into root 3, 2 root 3. 2 into I is 2i. Serious? 2 root 3 is nothing but 3 plus 2 into 3. Check it carefully. 2 root 3 into root 3 is 3. Next still I is present. Next plus into plus 2 root 3 I into I square value is minus 1. Check here. This is plus 2 root 3 plus root 3 plus 2i. This is 6i, which gives 8i. Plus into minus 2 root 3. Both will cancel. 8i. Only 8i is present. There is absence of real. Therefore, is purely imaginary. When for n equal to 3, root 3 plus I whole power n is purely imaginary. Next I need to find for real. How to find real? Finding real is very easy one. Root 3 plus I the whole cube is equal to 8i. This is our purely imaginary. In right hand side, this I can make a constant. When I square comes, if it is I square comes, I square is nothing minus 1. So it becomes purely real. So squaring on both sides. On squaring on both sides, root 3 plus I, already cube is present, put whole square. Whole square is equal to 8i the whole square. 3 2s are 6. root 3 plus I whole power 6 is equal to 8 square is 64. I square is minus 1. Nothing but minus 64 is real. I got real value. So when for n is equal to what value? 6. For n equal to 6, root 3 plus I whole power n is real. In this we can finish our sum. Seventh sum, first subdivision, very important sum in public point of view. To prove first subdivision, 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10 is purely imaginary. So for purely imaginary we have saw one property, when z bar is equal to minus z, 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 we can say z is purely imaginary. We can say z is purely imaginary. The same concept I am going to use here. So first assumption, let z is equal to 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10. Listen carefully. This is z. This is z. I was once told, if z bar is equal to minus z, then you can say purely imaginary. So this is z. See nicely, 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10. This is z. Taking conjugate on both sides. Taking conjugate on both sides. Take left hand side conjugate, bar, z bar. This also 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10 bar. Taking bar on both sides. This is a must, taking bar on both sides. You know the one property. What is the property? z1 minus z2, the whole bar. We can write as z1 bar minus z2 bar. The same whole bar, I am going to separate the bar for z1 and z2. So z bar is equal to 2 plus I root 3 whole power 10 bar minus 2 minus I root 3 whole power 10 bar. Z bar is equal to this. No, how to remove the bar? Conjugate. This plus sign I need to change minus 2 minus I root 3 whole power 10 minus this minus I need to change to plus 2 plus I root 3 whole power 10 to remove the bar. Still what I am going to do? Z bar, I am going to take minus common in this expression. Take minus outside and show this plus will become minus. Minus 2 minus I root 3 whole power 10. This minus will become plus 2 plus I root 3 whole power 10. So in this we are finishing the expression very easily. Check it. See, z bar is equal to minus 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10. 2 plus I root 3 whole power 10 minus 2 minus I root 3 whole power 10, nothing but z. This whole expression is nothing but z. So z bar is equal to minus z. Since z bar is equal to minus z, we can say z is purely imaginary. Therefore z bar is equal to minus z, which implies z is purely imaginary. Using the property, if z bar is equal to minus z, we can say z is purely imaginary. That's all. Simple format. Z bar is equal to minus z. We need to take this one as z, take in conjugate on both sides, removing the conjugate for each and every term. After taking bar, so minus, taking bar, so plus, taking, if you want, you can put one taking minus outside, taking minus outside, take minus common, so it becomes minus, and this become minus, this become plus. So we have got the answer. The first proof we have finished. Next we are going to move towards the second proof. To prove second subdivision, 19 minus 7i divided by 9 plus I whole power 12 plus 20 minus 5i divided by 7 minus 6i whole power 12 is real. Real means nothing but z is equal to z bar. This is one of the important sum. So in this, what I am going to check? I am going to consider this one alone. Consider this part without the power. This part without the power. 19 minus 7i divided by 9 plus I. I am going to conjugate 19 minus 7i divided by 9 plus I into 9 minus I divided by 9 minus I. This is a conjugate. Plus I means minus I minus I. So first I am going to multiply. 19 into 9 is nothing but 171. 171. 19 into I is minus 19I. 7 9s are 63 minus 63I. Minus into minus plus 7 into I square value is minus 1. This is a format a plus b, a minus a plus ib, a minus ib. So 9 square plus 1 square. So 171 plus into minus minus, plus into minus minus. So what becomes 171 minus 7, 171 minus 7, which gives us 164. 164. 99 minus 63i, which gives minus 82i. Minus 82i. Divide by 9 square is 81, 1 square is 1, nothing but 82. Totally here 82 is common. If I going to take 82 outside, remaining is 2 minus I. Divide by 82. 82 I am going to cancel. After cancelling 82 and 82, I can apply 19 minus 7i divided by 9 plus I whole power 12 is equal to 2 minus I whole power 12. Now only I am applying the power. After conjugating, get the answer 2 minus I. I put 2 minus I. After getting 2 minus I, raising the powers, power 12, power 12. So keep it as it is. This is the main one. This is nothing but main one. This is the part 1. I am taking this part alone. The same thing for this part. I am going to take this part alone without power. 20 minus 5i divided by 7 minus 6i is equal to conjugate. 20 minus 5i divided by 7 minus 6i conjugate. 7 plus 6i divided by 7 plus 6i is equal to 27s are 140. 20 into 6. 20. 6 2s are 12. 120. If you are going to check it properly, 120. 120i. 26 are 120 plus 120i. 5 7s are 35. So it becomes minus 35i. Minus into plus minus 5 6 are 30. I square value is minus 1 divided by a minus ib, a plus ib is 7 square plus 6 square. A is 7, b is 6. So 140 minus into minus plus 30. So 140 plus 30, which gives us 170. 170. Next, this is 120. 120 minus 35, which gives us 85. What 85? Plus 85i divided by 7 square is 49. 7 square is 49. 49 plus 36 is also 85. Nothing but 85. The whole quantity 85 is common and numerator, so it becomes 2 plus I divided by 85. 85 cancel. Answer is 2 plus I. Now raising the powers. 20 minus 5i divided by 7 minus 6i. What is the power here? 12. The same 12 I can apply here. The same 12 I can apply. 2 plus I whole power 12. So, if you are going to fill up the answer properly, do this fill up properly. See, this one plus this one. This one answer is 2 minus I whole power 12. For this one answer is 2 minus I whole power 12. For this one answer is 2 plus I whole power 12. So 2 minus I whole power 12 plus 2 plus I whole power 12. So I am going to write, listen very carefully. This is one of the important concept, important thing. So nothing but 19 minus 7i, 9 plus I whole power 12 plus 20 minus 5i divided by 7 minus 6i whole power 12. What is the answer is nothing but this 2 minus I whole power 12 plus 2 plus I whole power 12. This one we have formed. This one is 2 minus I, this one is 2 plus I. Now I am going to consider let z is equal to 2 minus I whole power 12 plus 2 plus I whole power 12. Taking conjugate on both sides. Taking conjugate on both sides. So z bar is equal to 2 minus I whole power 12 plus 2 plus I whole power 12 bar. We know one of the formula. What is the formula? z1 plus z2 the whole bar we can separate as z1 bar plus z2 bar to another property. Using this property I am going to separate the conjugate. Z bar is equal to 2 minus I whole power 12 bar plus 2 plus I whole power 12 bar 12. So now Z bar is equal to 2 minus I, remaining the conjugate become 2 plus I whole power 12 plus 2 plus I which becomes 2 minus I whole power 12. So I am arrange it properly. Z bar is equal to Z bar, first arrange this one, 2 minus I whole power 12 plus arrange this one, 2 plus I whole power 12. Z bar is equal to we have assumed, what we assume, Z is nothing but 2 minus I whole power 12, 2 minus I whole power 12, 2 plus I whole power 12, 2 plus I whole power 12, nothing but Z. Therefore this expression nothing but Z. If Z bar is equal to Z, which implies what we know is, if Z bar is equal to Z, Z bar is equal to Z implies Z is real. You know, if Z is real, we can say Z is equal to Z bar. If Z bar is equal to Z, and we can say Z is real. So within this we finish in this exercise and the sum.